as promised, everything is around AI, yeah, but now we are changing a little bit to the hot topic of automotive industry. And when we talk about hot topic of automotive industry, I think we are all aware that software-defined vehicle is not the buzzword of the automotive industry. It's really the movement and the strategic orientation and the success factor for the automotive industry. And I'm really, really happy to have Francis Chow here from Red Hat. Yeah, and Francis, thank you very much for joining, for coming. I think this is a first pitch you're doing here.
Yes.
And a sneak preview. I think we will have a panel afterwards together with BMW and ETAS. Yeah, so happy to enhance this discussion, what we are learning right now here. And if we talk about SDV and if we talk about Red Hat in the context of SDV, I'm really proud that we are somehow in a joint company, yeah, and bringing IT technology, Linux in the car. Francis, stage is yours. Thank you.
Thank you. Good afternoon, everyone. My name is Francis Chow. I am responsible for the Edge business at Red Hat with a focus on automotive. The industry has been talking about software-defined vehicle for more than a decade. But today, there's been limited progress made on this transformation. So today, I want to talk about how open collaboration could potentially help accelerate this journey. But first of all, I want to share a personal story. I was born and raised in Hong Kong, and when I grew up, I lived on an 8-story apartment, and my favorite restaurant was at the downstairs of where we lived. The owner of the restaurant, he was in his late 40s, and he was using an abacus to do all the calculations. I was honestly quite impressed on how fast and how accurate he does all the calculations, but I couldn't help but ask, why wouldn't you use a cash register? And he said, well, kid, I've been using an abacus for more than 30 years. I'm good at it. I know how to use it. Why would I want to take a risk on this new technology? Do you know it's going to work 100% of the time? Well, I didn't know. But by now, we knew that the cash register was widely adopted in the retail industry and in the restaurant industry. And over time, that cash register evolved into a computer terminal that does not just do calculations, but also keep track of finance and accounting. And over time, that evolves into a small computer cluster that sits at the back of the restaurant that can also monitor the video feed from a surveillance camera. It might even keep track of a customer loyalty program, or even create some new menu items with Gen AI on a weekly basis. Now, these technology innovations wouldn't have happened if the store owner did not choose to adopt new technologies in the beginning. Now, that moment of choice to adopt disruptive technology, I call it the cash register moment. The automotive industry is going through a cash register moment right now. I hope by now you would agree that SDV transition is not optional. Consumer expecting more technology in the car, richer features, safer autonomous driving, more personalization with the ecosystem, and that really create a lot of complexity in the electronic systems. Meanwhile, hardware has progressed along with Moore's law. Now you can have a very small form factor system on chip powering a lot of functions with low power. But that hardware device needs to have a good operating system and optimized software to take advantage of all these key features. Now, speaking of software, in the last 15 years, software has advanced a lot in terms of capability and productivity. Now, all these automations that happened in the last 15 years has really created a lot of opportunities for software-defined industries. Now, with the advent of AI, this is raising the bar even higher. We're looking at a lot of productivity with AI-assisted coding. A lot of new entrants are able to take advantage of these new technologies. You look at the Chinese OEMs, they're able to design a car in about 18 months design cycle compared to the 3 to 4 years that traditional Western OEMs are taking. Now, in terms of valuation, you look at Tesla, their market cap is bigger than the top 20 automakers combined. By the way, they ship about 2% of the global car volume, and the top 20 car makers ship a combined about 91% of global car volume. But Tesla has a bigger market cap. Now, if you agree the stock market is a future discount mechanism, it's very clear what the investors are looking for the future for SDV. We spend a lot of time talking to global OEMs. I would say every one of them want to make this change. But many of them don't really know how to do that, or don't have the skill or the budget to do it cost effectively. But the challenge is this. Consider you're a traditional OEM in the Western world, and you're not quite sure how to make the change. So you decide, okay, we're just going to wait for a generation before we adopt new technology for software-defined vehicle. Now, if you play this out in time, it's going to take you 3 years to design for your next generation platform. By the time you're done with that, your cutting-edge competition will have created 2 generations of software-defined vehicle. So now you're 3 generations behind, which would look pretty obvious to you at that time that you're behind. So you kind of make a change, which, because you're doing it the first time at that point, it's going to take you probably 3 years to get to a first software-defined vehicle platform. By then, you're 4 to 5 generations behind competition. It is extremely difficult for you to catch up when you are 4 to 5 generations behind. And at that time, I think only inorganic options are left on the table, meaning bankruptcy, getting acquired, or you can acquire someone with the right technology, assuming you have the capital. So SDV is not only non-optional, it is actually existential to the automotive industry. The superficial understanding of SDV is, hey, we need to be able to update applications and services, maybe over the air. But I think you have to kind of take a look deeper on each layer of the technology stack. If we're able to adopt the right technology in each layer of the stack, then software-defined vehicle adoption actually becomes more natural. But this is not just about product. You cannot just swap in the right product and say, hey, okay, now SDV is done. You have to rethink the way you do your processes. So you have to combine holistically on how you design SDV with the right technology with a process change. So I'm going to talk a little bit more about the process, and then we'll come back to the product. The way we've been designing electronic systems in automotive, that this is the old world, it is very hardware-centric. You have your A, B, C, D hardware samples. Once you get your A sample, you start thinking about your software platform development. And after your platform mature a little bit, you start to think about your application development. This serial ways of thinking takes you a long time to design your platform. There's a lot of hardware dependencies, which makes it very difficult for you to debug. And it, again, takes a long time for you to finish your software development. And once you get to SOP, your solid production, future updates also is slow and costly. Now, in the current world, most of the OEMs have adopted what we call a shift left. Right? You're trying to do your software development and testing earlier on your design cycle. And with a virtual hardware platform, in today's days, most emulation-based, many companies are able to shift left a little bit. So you can do your software development a little bit early in the cycle. You can do some early testing. But because your whole design approach is still very hardware-centric, even though you can improve your solid production day by a little bit, it is not enough for software-defined vehicle. Now, what we propose for the new world is you need to have a software-centric and open source-led approach. I'm going to first talk about software-centric, what that means. What software-centric means is that you need to abstract your software development from your hardware. That means you should not be dependent on your hardware when you develop your software. You shouldn't be designing your software every time you choose a new hardware platform or a new program. There should be one software platform that lasts until the end of time, and you can develop it independent of hardware. Now, when your hardware platform is ready, then you just do your hardware integration and testing. And with this approach, you should be able to compress your development time, because so you're no longer dependent on hardware, and you get the production sooner, and you can do an OTA for future updates a lot easier. Now, if you want to start even earlier, yes, you can compress the time, but there's a way to actually start earlier, is to leverage open source. Imagine today if you want to do some collaboration on R&D, or you want to do a cross-license or JV, it would take months, if not quarters, to negotiate that type of contract. Even if you try to procure software, hardware, it would take you weeks, if not months, to negotiate a contract. But if you start with open source, you can actually start tomorrow. You don't have to wait. Well, you have the ability to start kicking the tires as quickly as you can. So now with a combination of software-centric approach and open source-led, not only you can compress the design time, you can bring the beginning of the design time a lot earlier in the cycle. And this is what is needed, right? So for software-defined vehicle and for automotive companies to remain competitive. Now, I talked a little bit about earlier that you need to have a software platform that is abstract from the hardware. Well, you may ask, how is that even possible? Well, you have to look at what software layer allows you to do that. And the key thing is you have to kind of think about what choices you have to think about for your fundamental operating system, right? This is a layer allows you to do the abstraction. And in fact, right, let's take a look at holistically, what are the design criteria of this operating system. And our suggestion is you need to take a look at 3 different levels, or 3 different categories. You want to take a look at development agility. What that means is you should be able to develop your platform with flexibility and agility and quickly. And then you need to look at your system architecture. You're not just designing a system for the next program or the program after that. You want to have a system architecture that is future-proof, so that it stands the test of time for the next 10 years, 20 years. And you want to have a sustainable operating model, which means you need to have a way in such a way that, design in such a way that you design a system, but the next time you design it, it shouldn't take you as much money or time to do it. You should be much more efficient when you do it the second one. And if you are doing updates and upgrade, it should be minimal cost so that you're effective in your operation. Now, within these 3 categories, we have to look at different areas within these 3 categories. So it becomes a 3x3 matrix. Right? I'm not consulting, otherwise it would have been 2x2, but let's look at 3x3. Now, for development agility, the 3 areas that we think you should look at. Number 1, cloud-native support. By now, it's been well proven in the software world that cloud-native is the most effective way to design software. It doesn't mean that you're deploying your software in the cloud. You're just using the cloud-native principles on designing software. Take advantage of the tools. Take advantage of the resources available to design software quickly. You need to be able to do virtual testing, because instead of testing tens of thousands of vehicles in hardware and miles, and now there's technology to allow you to do tens of thousands of cars testing overnight in the cloud. You need to be able to think about taking advantage of this technology to accelerate your testing and validation. And you need to take advantage of AI-driven development. Now, to state-of-the-art AI, what we are actually experiencing firsthand, you can actually spend an hour on an AI tool like Hot Code or Gemini or ChatGPT, and that can actually produce equivalent of a month of engineering work. Now, if you think about that, right, that's 150 times improvement in productivity. Now, yes, if you look at the whole program, the whole project, there's no way you can achieve that productivity. But even if you gain a 5 times or 10 times improvement, right, that is very significant on how we design products in the future. Now, on a system architecture point of view, of course, right, if you choose an OS, it got to be safety certified. Right? This is table stake. We have to have functional safety compliance. The second point about system architecture, I think it is important, is mixed criticality. Right now, a lot of the systems, you have a hypervisor, you have an OS to support a safe workload, and then you need a different hypervisor and OS to support a non-safe workload. If you really want to have a scalable architecture, your OS, your operating system, should support both safe and unsafe workloads so that you can actually have a lot more flexibility on system designs. And the third point is real-time. Right? Of course, right, if you're in a vehicle, real-time operation is also table stake. The third category is sustained operation. Certainly, in the SDV world, we have to be able to do regular updates. Right? That needs to be painless and frequent. And you need to have the hardware flexibility. Right? You should no longer be tied to hardware. We talked about that earlier. Your software needs to be abstract from the hardware layer. And last but not least, if you think about how software should be changeable over time, over the lifetime of the vehicle, you need to have a way to continuously certify safety on your whole software platform. So you need to have an approach to do that. Now, just like any science study, what I'm trying to do next is to have a hypothesis, and then I'm going to try to validate the hypothesis to see if the hypothesis is going to fit into this 9 criteria of selection for an operating system. And my hypothesis is Linux is the right solution for an operating system for software-defined vehicle. And we also believe Linux is the enabler of a lot of the capabilities that is needed for software-defined vehicle moving forward. So let's take a look at some facts, right? These are not opinion, right? These are facts, and let's kind of go over that one by one to see how that fit into the whole picture. Linux have taken part an important role into transforming many industries in the past 20 years. The data centers that we know today now is mostly standardized on Linux. Software-defined data center is standardized through Linux. If you look at the telecom network, as we know, software-defined networking over the last 10 years was mostly standardized and mostly adopted through Linux. Right? In fact, today, more than 2.5 billion mobile subscribers are connecting to the network through open source code. Industrial 4.0, the software-defined industrial systems are also being transformed with Linux. So we have a lot of history demonstrating that Linux is capable of helping multiple industries transform themselves into a software-defined world. So we believe automotive is now at the right time. This is the cash register moment to think about transformation to software-defined. Now, looking at some of the, again, facts and attributes about Linux. Today, more than 90% of the public cloud infrastructure runs on Linux. Right? This is an undeniable fact, right? The public cloud, everyone now uses public cloud, every company uses public cloud. 90% of those servers runs on Linux. And Linux has been also proven to support a diverse set of hardware architectures, whether this is x86 or ARM or RISC-V for the future. Linux already support those. And Linux also have a long history of standardizing hardware and abstracting that hardware layer away from software. Right? Today, if you're in IT, you're developing applications, you don't really need to ask whether that hardware is supported by Linux or not, right? Because it's already standardized. And we think that transformation can happen with software-defined vehicle. And last but not least, very important. I hope everyone would agree that AI is here to stay. where we're going to have AI in our vehicle in the foreseeable future. All of the top AI models are developed on Linux today. All of the prominent AI coding assistant tools are optimized for Linux. Why? Because Linux is the most ubiquitous operating systems in the world. This is where most of the programmers are programming for Linux. So it makes a lot of sense for all these AI tools to be optimized for Linux. So it becomes more natural for Linux to be a primary sort of first-class citizen for AI moving forward. Now let's try to map it back to what we just showed before in terms of the 3x3 requirements, criteria for a software-defined vehicle. What we look at, again, this is quite factual, is that 5 out of the 9 criteria that we talk about are native for Linux. What I mean by native, it means Linux is a first-class citizen for these areas. It is natural for Linux to do that. Let's just kind of use some examples. Cloud native, as I said, 90% of the cloud servers are using Linux. It's natural for Linux to support cloud native development. AI, we talk about that. It's natural for Linux to support AI. We know Linux already supports virtual testing today, where we have a lot of examples, including Volkswagen has been adopting Linux and share that publicly, right? They have been able to reduce the system test costs by 50%, leveraging virtual testing. Regular updates. Linux is known to be regular updatable, right, in IT, so this is something that we know that works. Native, again. Hardware abstraction, we talk about that. It's native to Linux. So all these areas, we believe native is really the first choice because it's so natural for that. Now, for other areas, Linux, I think, is quite competitive. Specifically for Red Hat's operating system that we just announced back in May this year, we have achieved a safety certification on ASIL-B out of context as a safety element for our Linux product. Now we have a safety certified Linux product in the market for automotive applications up to ASIL-B. Mixed criticality, again, the product that we build support mixed criticality. We are competitive on those areas. Real time, we're quite comfortable with operations of under 100 microseconds with max latency. So this works for almost all the ASIL-B applications that you can think of in a vehicle. And last but not least, leveraging our expertise in software automation, we have created the continuous safety certification approach, whereas you create all these updates and upgrades, just as very common in IT today, you don't have to redo the safety certifications like you did today, which takes a lot of time and effort and money. So we think Linux should be a good choice for your foundational operating system moving forward for software-defined vehicle. Let's take a look at how that would work in practice. So if you kind of think about a typical development flow tomorrow for software-defined vehicle, you would want to start from the cloud, because for a couple dollars an hour, you don't have to buy your own infrastructure. You don't have to procure your hardware. You can actually start kicking the tires tomorrow in one of the public cloud vendors with all the code actually available now publicly in open source. You can kick the tires tomorrow for a couple bucks. Now, as you figure out how you want to play around with your architecture and you get a bit more serious about what hardware choices you want to make, you can then do your virtual platform simulations. This is your second step, right? This type of products, like coming from Siemens or Corellium or Synopsys, they give you pretty accurate hardware constraints, and you can actually develop software on these virtual platforms. And then once your software becomes a bit more mature, then you can move to your hardware, and you can start your hardware integration and testing. Now, this is made possible when you have a consistent underlying operating system across these steps. Today, those are different. You have different hardware, different OS in each of the 3 steps. Now, the problem is you made a bug fix on your step 1 and the step 2. You have to redo it on hardware because it's a different hardware dependency. A lot of the effort you have to redo, and it's really not scalable. But when you have a consistent platform, you can actually go through all this step of development in the same setup in different environments. And then I want to push the concept a little bit upstack to talk about this is actually not just about the operating system that can be open source. We should think about what else can be open source. In our opinion, anything above hardware and below the application can be and should be open source. And the reason why we think that way is because those layers are what we call non-differentiating layers. Consumers don't buy a vehicle from an OEM because of an OS choice or a middleware choice. They choose a vehicle because of the driving experience or the brand, which mostly come from the application layer. So we think the middle part of the stack, right, the OS and the middleware, should be standardized, should be open source. And that way, the industry as a whole can actually share resources. We can develop those stacks, standardize them, and benefit everyone that way in a way more cost-effective manner. And in fact, Eclipse is now hosting a project called S-Core that does just that. And in about 30 minutes, right at 2:30, I'll be actually moderating a panel to talk about, now in practice, how the community, working with the OEMs and Tier 1s and Eclipse Foundation, are putting that in practice to put open source and open collaboration into automotive world. So stay tuned for that panel in about 30 minutes. Now to wrap up, we know SDV is a long journey. It does take a lot of effort. It is disruptive, right? Because we know this is like the cash register moment of the retail industry and the restaurant industry. It is disruptive, but unless we decide to adopt new technology, we will be stuck in the abacus world. This is the cash register moment for the industry. The time is now. It is time to act. And if there's anything that Red Hat can do to help you with this journey, we're here to collaborate and figure out a way to get there in the open source way. Thank you very much.
So, Francis, thank you very much for this inspiring presentation. And just you said, it's just the beginning. Or in 30 minutes time frame, we will have also, I think, an engaging panel. But if you want, I think we can take one question. If there's one question from the audience, I think there's time. Then maybe we save the question then for later.
We'll save the question for the panel.
For the panel.
All right.
Thank you very much.
Thank you very much.
Thank you very much.